So we have 1, 8, 27, 64, 125, 216, 343, 512, 729, and then 1000. And again, you can make this list super easy for a quiz or a test. You just do 1 times 1 times 1 gives you 1, 2 times 2 times 2 is 8, 3 times 3 times 3 gives you 27, etc. So for our first example, look for GCF, no GCF. It's a binomial. It's subtraction. This time, x cubed is a perfect cube, and 125 is a perfect cube. So I'm going to do something slightly different. We have a smaller parenthesis, and then we're going to have a longer parenthesis. In my small parenthesis, I just cube root both terms. So x and 5. For my longer parenthesis, I'm going to use these terms. So I'm going to square the first term. X times x is x squared. Multiply the two terms together, 5x, and then square my last term, so 25. And then for the signs, I do SOAP. Same sign as the problem, opposite sign, always positive. I look to see if I have any more GCFs or anything else I can do. I cannot. That is my answer. For 10, it says x cubed plus 8. There is no GCF, but x cubed is on my perfect cube list. 8's on my perfect cube list, and it's a plus sign, which is fine. So I'm going to do my small parenthesis, my longer one. Cube root of x cubed is x. Cube root of 8 is 2. Square the first term, x squared. Multiply the two together, 2x. Square the last term, 4. Our signs are from SOAP. Same sign as the problem, so it's positive. Opposite sign, always positive. For 11, 27x cubed minus 125. There is no GCF. 27 is on my list of perfect cubes. 125 is on my list. And then x cubed is obviously a perfect cube. So I'm going to do my small parentheses and my longer parentheses. Cube root of 27 is 3, so we're going to have 3x. And then cube root of 125 is 5. Square the first term, so I'm going to do 3x squared, so that's going to be 9x squared, or 3x times 3x. Multiply the two together, so that gives me 15x. Square my last term, 25. And then same, I start with negative, opposite, always positive. For 12, again, we look for a GCF, no GCF. It's a binomial. I see cube, so I'm hoping it's a perfect cube problem. 64 is on my list, so it is. I'm going to have my smaller parentheses, my longer one. Cube root of 64 is 4. And then x for x cubed, cube root of y cubed is just y. 4x times 4x is 16x squared. And then we multiply them together, so that's 4xy, and then we're going to square the y. Same sign, so it's going to be minus. Opposite, always positive. When I look at 13, I see, oh, there's a GCF of 5. So I'm going to pull that out first. 5 divided by 5 is 1. So we get 1 plus n cubed. And then people always assume that's not perfect cubes. 1 is on our perfect cube list. N cubed is a perfect cube. So I can go one step further. There's small parentheses, longer parentheses. Cube root